So welcome to Senior Chemistry and our unit on structure and bonding, in which we will begin with types of bonding. Okay, so in order to consider types of bonding, we must consider the stability of different types of compounds. Chemical reactions occur to substances to allow them to become more stable. So the reactants are more stable than the products. The formation of a bond usually results in a more stable product compared to the reactants. For this reason, atoms with incomplete outer shells or valence shells will gain or lose electrons or even share electrons to allow them to become more stable than they initially are. So most natural substances do not consist of isolated atoms. They consist of elements or compounds in which the atom is bound strongly to another atom by chemical bonds. A chemical bond is an electrostatic force of attraction between a positively and negatively charged species. There are two broad general ways that atoms combine to form compounds. Either electrons are shared between atoms or they're transferred between atoms. Okay, so natural substances are not single atoms, and when a chemical bond forms, there is a tendency for atoms to acquire the electron configuration of the closest inert gas in group 8. This is known, in short, as the octet rule. So chemical bonds are electrostatic attractions between atoms. So two broad ways in which attraction occurs, either by the sharing of electrons or by the transfer of electrons. There's a little cartoon there in terms of ionic bonding between the positive ions of, say, sodium, and negative ions formed with bromide and chloride. So the types of bonds. So this year you will investigate and learn to describe three types of bonds: ionic bonding, covalent bonding, and the third one, metallic bonding. So we'll look at ionic bonding first. So this is a form of bonding that occurs between a metal cation, or a positive metal ion, and a non-metal anion, or a negative non-metal ion. The particles involved are ions, an atom which has, or group of atoms which has a net positive or negative charge. They've lost or gained electrons. And you should be familiar from these from the ion identification lessons in the previous units. So how do you form ions? Well, ions are formed when an atom, as in the previous slide I discussed, gains or loses electrons. For metal atoms, they generally form cations, and the way they do this is by losing an electron to form a positively charged species, a cation. And in terms of non-metal ions, they are formed from non-metal atoms where the atom gains electrons to form a negatively charged species because there's more electrons. Okay, so here's an example of a molecule which has ionic bonding, table salt or sodium chloride. So as you can see, the sodium atom has a spare electron on its outer ring, its outer valence ring, which is to give that electron away in order to become stable, either having a 2 or 8 electrons and having a full outer shell. In order to do this, it gives its electron away to a chlorine atom, which gains a negative charge from the negative electron to become the chloride ion. So it's gone from chlorine to chloride ion. Because the chloride ion becomes stable when it gains the extra electron, so its valence shell becomes full, it becomes 8. So you end up with the positive sodium ion getting attracted electrostatically to the negative chloride ion, and we get a strong bond called sodium, and sodium chloride called the ionic bond. So in order to define an ionic bond is the bond formed between an atom that has lost electrons and become positive and an atom that's gained electrons and become negative. And it's the strong electrostatic attraction between the negative and positive ions which forms the ionic bond. So shared electrons come from the valence shell of the atom sharing electrons in covalent bonds, and they're found between the nuclei of both atoms. When groups of atoms bond covalently, molecules are formed, such as hydrogen gas or carbon dioxide. Within the bond, the negative bonding electrons are attracted to the positive nucleus of both the bonding atoms. As a result, there is a sharing of electrons. Okay, so electrons in this bond are shared. They can be single or double or even triple covalent bonds with 2 electrons per bond formed. Okay, and these electrons are called the bonding electrons. The octet rule limits an atom to have 4 pairs in its valence shell, because 4 times 2 equals 8. However, there are some exceptions which will be discussed at a later date. Okay, so that means that the electrons simultaneously belong to each atom in the covalent bond, and they usually form between non-metal atoms. Okay, so in terms of finding a covalent bond is a chemical bond formed by the sharing of 1 or more electrons, especially in pairs of electrons between the atoms. So where ionic bonds where 1 electron is taken or given, in this case both atoms share the electrons. Here's an example here of a hydrogen. So you've got one hydrogen atom with an electron and a proton, another hydrogen atom with an electron and a proton, and these two share the electrons because that way they end up with a full outer shell of 2. This is known as a covalent bond. Even more examples there, comparing and contrasting the covalent bond with the ionic bond. So in the covalent bond, the 2 electrons are shared, whereas in the ionic bond, the positive ion is formed and the negative ion is formed by electrons being transferred, and it's the attraction electrostatically which creates the bond. So finally, the effect of bonding. Chemical bonding will influence the physical properties of matter, and the physical properties will depend on the type of particle, the atom, ions or molecules present, and the forces of attraction between the particles. And it's the force of attraction that is determined by the chemical bonding, which we're going to go into the next lesson.